3x squared equals 80 minus 5. So we've gotten rid of this 5 by subtracting it on both sides. So we get 3x squared equals 75. We divide both sides by 3, so we get x squared. So we get x squared equals 75 divided by 3. X squared is equal to 25, so x is equal to the positive or negative square root of 25. So positive or negative 5. So we get x equals 5 or negative 5. Remember, the square root of a number could be a positive or a negative value. Therefore, whenever we take the square root of a number, we place a plus or minus symbol in front of the square root as indicated above. Quadratic relations are modeled by graphs that are parabolas. For example, the quadratic relation y equals x squared plus 8x plus 12 is modeled by the graph below. Here it is. The quadratic equation represents the values of a quadratic relation at a specific time. So here, or at x is minus 1, y is equal to plus 5. We could also determine this without a graph. So, if y equals x squared plus 8x plus 12, we want to know what y would equal when x is negative 1. We would substitute negative 1 in for x. So we get y equals 1 minus 8 plus 12. Y equals 5. So when y equals 5, x equals negative 1. It also equals negative 7. We could also determine this if we solve the following quadratic equation algebraically. 5 equals x squared plus 8x plus 12. So let's solve it algebraically. We would take away the 0. We would take away the 5 to give us 0. And we take away 5 on the other side. So now we have x squared plus 8x plus 7, which is equal to 0. 0 equals x plus 7, x plus 1. We factor this trinomial above. So, for this to equal 0, x plus 7 is 0, or x plus 1 is 0. So on this side, x is equal to 7, negative 7, and on this side, x is equal to negative 1. So this quadratic equation is represented by 2 points. Negative 5, negative 7, comma 5, and negative 1, comma 5. Compare. Equation versus relation. Here's the equation. And the relation is this. The equation has only one variable, whereas the relation has 2.